Well, welcome back to another fantastic, wonderful, out-of-this-world episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
I'm your host for this summer, Heidi Campo, and joining me is our stupendous, spectacular Professor Fred Watson, astronomer at large. Hello, Fred. How are you doing on this wonderful morning of yours, afternoon of mine?
Yeah, pretty good, thank you, Heidi. The sun is shining. It was very foggy first thing. And of course, we're not in summer, we're in winter. So you're with us for the whole winter. Yesterday is the first day of winter in Australia. They start the seasons on the 1st of the month. So the 1st of June is the first day of winter. And it was a nice day yesterday as well. Typically, weather here is cold and sunny. And by cold, I mean, 12, 13, 14 Celsius, something like that, up to about, it's 60 degrees Fahrenheit will be cool for us.
That's good weather. I think that the 60s, the 70s are perfect. When you start getting into the Houston heat and humidity and you're working in the blistering 90s with, 80% humidity, I think people tend to start not enjoying that as much.
No, I understand.
So we have some really fun topics today. Today we are looking at all sorts of things from space bubbles to pancake volcanoes. This sounds like we're making a recipe. And we're finishing off with celebrating 50 years of the European Space Agency with some special collector's items. So without further ado, let's jump right into today's topics.
Yeah, thanks, Heidi. And I love this first story, partly because it is visually completely inspiring, and I'll point our listeners to the website in a minute, but also because it's research. It's got a cast of thousands, like many research topics do these days, but it's led by a good friend of mine, Miroslav Filipovic. Sorry, Miroslav, if you're listening. He's the Professor of Astronomy and Astrophysics at Western Sydney University. And in fact, I have an honorary appointment with the university, so I know Miroslav well. He's a very able radio astronomer with many really important pieces of work under his belt. But I think this one is not just spectacular from a scientific point of view, but it is incredibly beautiful, because what in fact, I think he made the initial discovery himself. What they've discovered is it's being called a cosmic bubble, but it is perfectly circular to our eyes, which means it's probably perfectly spherical. If you want to have a look at it, the news item I was looking at is actually on space.com, but I think it's being covered by many of the science news outlets. And the title of that space.com page is a quote from Miroslav, one of the most geometrically perfect. And they ask, what is this mysterious sphere deep in the Milky Way galaxy? So what we've got is, it comes from a radio image of the sky taken with one of the great new radio telescopes here in Australia, an instrument called ASCAP. ASCAP is situated in Western Australia at a site which has a long name. It's the Murchison Radio Astronomy Observatory in Yarimana Ilgari Bundara. And the last three words of that name are Wadjuri language. They're the traditional owners of that site, and it's a Wadjuri expression meaning sharing sky and stars. So it's a very well-named observatory site. Now, that is where the what's called SKA Low, the Australian half of the Square Kilometre Array Observatory's big new telescope that's currently being built there. And I think we've talked about it before, Heidi, the fact that it's not a steerable dish. This is a telescope that looks like a forest full of Christmas trees, metal Christmas trees, which stand there and are steered electronically. It's extraordinary technology. But as well as that, there is a set of, I think it's 36, if I remember rightly, steerable dishes which form what is called ASCAP, the Australian Square Kilometre Array Pathfinder. And that was the instrument that Miroslav and his colleagues used to find this curious object. They, in fact, it was one of the surveys, publicly available surveys of the sky, the radio sky, that have come from ASCAP. And he spotted, because of his eagle eyes in the readouts, he spotted this ring of material. It's got a few oddities about it. First of all, as I said already, it's perfectly spherical. We see it as a circle, but it's almost certainly a sphere because we don't look from any preferred direction. But the other thing is that it only emits its radiation at radio wavelengths. And there's just a hint of visible light coming from hydrogen, but most of it is radio wavelengths. And that flies in the face of what we know about objects of this kind, because it is probably what's called a supernova remnant, a bubble in space which comes from an exploding star, probably centuries ago, maybe, because they haven't quite figured out how big this thing is yet, but an exploding star that's kind of carved a cavity in the gas in which it's immersed. And that gas is very rarefied. It's what we call the interstellar medium. But when you get an explosion, it will carve out that sort of spherical chamber. So that's what they are assuming it is. The kind of important bit I haven't mentioned, which is that they've given it a lovely name, which is Telios. It is spelt with T-E-L-E-I-O-S, and it's a Greek word meaning perfection. And that's because it is. It's a perfect looking sphere. Quite extraordinary.
It really is beautiful. It looks like just this cosmic marble floating. But the other interesting thing to me that maybe you can explain a little bit more, I'm sure half of your listeners probably already know this, but some of us don't. But the sphere has this greenish, blackish tint to it, but so does all the other matter around it. So what is making up this sphere versus the matter around it that's distinct but looks the same color-wise?
So the color that you're seeing is, remember, we're looking at radio wavelengths. We're not looking at, a visible light image. And so the color comes from the processing that has been done to this image. And it's probably... there's a color bar. I actually looked at the original paper that gives you essentially a scale of intensities that refer to the color. So what you're saying is a measure of brightness, and you're absolutely right. The thing is the same color as its background, but what delineates it is this abrupt kind of step from the intensity of the marble itself, if I can call it. That's a really good word because it looks exactly like that. The step in intensity from that to the background, which is a lower intensity, and so it's what we're seeing there is the radio data interpreted as color, and the greenish. Is I think that's just one that they've chosen for that level of intensity. That space.com page that I mentioned earlier has another of, it's got the original map, the original radio map, I think, that is the one that Miroslav used to find Telios. And you can see there that the color is orange. Once again, it's an artificial color. So we're not looking at anything actually astrophysical with that color.
Yeah, so it's not measuring any kind of like a density, like a ultrasound or anything like that. Because I do see different colors around it that I believe would be indicating differences in radio frequencies bouncing off. So, for example, that bright spot in the left corner is not a bright spot of sun reflection in the traditional sense of an image that we would see. What would that bright spot represent in radio imaging? That is where, if I remember rightly, because the article that I'm looking at doesn't have this, but I did look at the original paper. I think that's where there is a little bit of visible emission
visible light emission. It's the color that we associate with hydrogen because we know that different elements emit light in different colors when they're excited, either by ultraviolet light or electrical electrified particles. And I think that's where the visible light color comes in. You're right. There's a it's almost like a whitish patch there. So I think the greenish stuff is the radio emission. I think you're right too that there are probably different frequencies depicted here, and they too might change the color, because you can do the same with radio waves as we do with visible light. The reason why we see different colors is that we're seeing different wavelengths of light. So what you can do with radio radiation, you've got these receivers which are basically giving you different frequencies of radio waves, and you can assign colors to them and make an image like this. I think that's probably what's happened.
Okay, that makes a lot of sense. I also kind of asked that. This is a little bit funny, but I found a comment on that article from a conspiracy theorist who is claiming that this is undoubtedly an altered. So he thinks it's a telescope image, and he thinks that they have altered the lens to hide intelligent life that's hiding behind that spot. And so I think that's why sometimes it is just so important for people who don't understand the science to take a step back and just go, okay, first of all, this is not a telescope image we're looking at. This is a sound radio frequency translated to a visual medium for us to be able to understand what those waves meant. And then for somebody who doesn't understand what that means, they can maybe, I don't know, jump to some crazy conclusions. So at the end of the day, it's always so important to understand how we're getting what we're looking at, and then what we're looking at even means. So thank you for clarifying that.
It does, it's interesting that you mentioned conspiracy theories, because it does have such a perfect circular feature that it looks artificial. It's not. It's definitely a supernova remnant, one of these bubbles. But yes, it does look like something that's been made by intelligent life, but we don't believe it has.
Well, those pancakes also look pretty circular. Maybe this is a theme in space. Does space like circles?
It does, actually. And you've hit the nail on the head, Heidi, because we've got 3 stories today that all involve circles. And this one is no less spectacular, actually, than the previous one. So we were talking about very, very regular circular features on the planet Venus. And Venus, as I guess most of our listeners know, Heidi, is surrounded by a thick, opaque atmosphere that means that we cannot penetrate it very easily. Although I should say that one of the outstanding features of the Anglo-Australian telescope, the telescope that I used to be the astronomer in charge of, very early in its history, it actually saw the surface of Venus through those clouds using infrared radiation. Only a glimpse, but it did see enough of the surface. But the best way to see the surface of Venus, unless you land a spacecraft on it, which the former Soviet Union did a number of times in the 1980s, and sent us back some pictures of the surface. But the best way to see it from above is by radar. And NASA's Magellan spacecraft back in the 1990s mapped the whole of Venus's surface with radar. And so we've effectively got very clear images, quite high resolution images of the surface of Venus, which show mountains and valleys and yes, volcanoes. But they also show these really weird features, the ones that are very, very circular. They're called pancake domes. And they actually look more like impact craters, those craters that we're so familiar with on the moon, where meteorites and small asteroids.
Thinking the same thing.
Yeah, landed. But they're not. They apparently are tectonic features. They come from volcanism in the planet. They do look just like pancakes, I have to say.
They really do. They almost like with the crust and everything. Like they just like the pancake that was just cooked. Maybe we're supposed to take it off the stove just a minute before.
That's probably right. Yes, just before the edge started turning up, which has happened there. So they're not volcanoes in the way that we normally think of one. The common volcanoes that we think of here on Earth, the stratovolcanoes, the ones that look like Mount Vesuvius, very conical, or we've got the shield volcanoes like Mauna Kea on Hawaii, which they're called shield volcanoes because they look like a shield. They're flat and with only gentle slopes rather than having, very, very steep sides. But these are quite different pancake domes. And the reason why they're in the news is that we've never really understood how they're formed. It's thought that it is something to do with pressure underneath the crust of Venus. And we see these domes, volcanic domes, on other worlds in the solar system. And I'm thinking particularly of Ceres, which is the largest of the asteroid. It's actually a dwarf planet, 900 kilometers across. Ceres has regions that look as though they should be a volcano, but there's no crater at the top. And what we're seeing is something underneath the crust of Ceres has welled up, and the pressure has caused this elevation of the landscape. So it pushes up this weird-looking dome. That, however, is quite different from what we're seeing on Venus, which our listeners are probably fed up of hearing now. They look like pancakes. And so the problem has been, how are these things formed? And one of them has been studied in detail. It's one of the largest of them. It's 90 miles or 145 kilometers in diameter. And again, it uses those radar data that we spoke about. So a group of scientists, I think they're led from the Georgia Institute of Technology in the USA, they've looked at theoretical models as to what you would need to produce such a curious feature on the surface of a planet like Venus. And they actually have an answer. They say, okay, it's a particular kind of lava that you need, coupled with a surface, a crust of Venus, which is particularly pliable. In other words, it's flexible. And in fact, we've seen other reports recently that suggest that the crust of Venus is not as rigid as the Earth's crust, that it is a bit more flexible. And now it's still pretty stiff compared with the kind of things, bending a piece of paper or something like that, but it's nevertheless more flexible than our crust is. So the numbers that they come up with are pretty spectacular. They need a very, very viscous lava. And the report that I've read, which is an article by Ashley Morgan on Daily Galaxy, describes it as being 1 trillion times thicker than ketchup and twice as dense as water.
What is up with all the food references?
Yeah. We're doing pretty well with the bubbles and the pancakes and all the rest of it. Anyway, what that means is you've got a lava that is very, very slow flowing. Not, as we see volcanoes on Earth where the lava's pouring down the mountainside. These actually move very slowly, hundreds of thousands of years to form a phenomenon like this. And if you mix that with the fact that the crust is flexible, then you get a model that actually is capable of simulating these pancake features. And that's quite extraordinary that you can just do that, with computer modeling. But you can actually make something in the computer that matches what we see exactly. And so that is why we think that's it's the new idea for the way these things form. Very, very different from the way features on our own planet form.
Well, and almost like, I'm sorry, I'm beating the dead horse, but if this was dough, we see how if the dough had risen and it was almost liquidy and that bubble kind of popped and then it softened back down, you see the same kind of lines and dimples that you would see on a cupcake that went flat or something like that. So it really, their line of logic makes perfect sense for even me, who has no geological background. So that's really quite interesting.
Yes, I agree. I think what you've described actually is probably a good model for the way these things formed. I suspect that what we're seeing as the surface of these things is actually the crust of Venus, which has been deformed into this shape by the pressure underneath of this very, very slow flowing magma. So if you do take the analog of the cookery, something's gone really terribly wrong with your cupcakes.
And that's just the recipe for a perfect planet. You can't leave it in the oven too long. You can't let it cool too much. If it's too hot, it'll be Venus. If it's too cold, it'll be Mars. Our planet is cooked to perfection. Our planet is the souffle of planets.
Let's take a little break from the show to tell you about our sponsor, Insta360, and their brand spanking new 360-degree camera, the X5. Now, at the end of this, I'll tell you how you can get a special bonus as a Space Nuts listener, being a free 114 centimetre invisible selfie stick. It's worth around $25 US, and you can get that if you buy the standard package through Insta360. So what is Insta360? Well, it's a camera, but it's no ordinary camera. This is a beautiful piece of equipment. It is their flagship model, and it can take footage 360 degrees. You don't have to point it at anything. You just start recording and it records everything around you, and then you can sort out what you want later on through their mobile phone app or cell phone app, and it works on Android and Apple. And it works in all sorts of situations. It works in low light. It works underwater. It has outstanding image quality. We're talking 8K 360-degree video. Night shooting, it's just changed the game in terms of night shooting. And as I said, you just need to start recording, and it will just focus on everything around you, and you can figure out what you want to do with that footage later, regardless. And it's AI powered. It has all these amazing AI powered tools that just make the job so much easier. On top of that, there are replaceable lenses. These lenses are made of very tough optical glass, and they are much better in terms of drop resistance than your average camera. And waterproofing to 15 metres or 49 feet. And the list goes on. They are fabulous. Also, the built-in wind guard. We don't think about that much, but wind can really mess up your audio, and they use an audio algorithm to get rid of that problem. So that's the product. If you would like to have a look at it, go to the store, store.insta360.com. That's store.insta360.com. And if you are one of the first 30 Space Nuts listeners to sign up for the standard package, you will pick up that 114 centimetre invisible selfie stick worth $24.99 US. So all you have to do is go to store.insta360.com for the Insta360 X5 standard package. That's store.insta360.com. And don't forget the promo code SpaceNuts. That's very important. So there it is. I'm sure you won't be disappointed. This is an amazing piece of equipment, and you'll have many hours of fun, and I'm sure whatever you do with it, whether it's domestic or professional, it will live up to the expectations. So that's store.insta360.com with the promo code SpaceNuts, and we'll have all that information in the show notes. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Well, pivoting away from food references, now that everyone is hungry, I am so sorry, but we are going to talk about the European Space Agency's 50-year anniversary special coins. And if any of you have ever been around coin collectors, military, people who have worked in government-type roles, coin collecting can be quite the hobby that people get really, really into, and going to different places, different organizations, collecting these rare coins is something that I think for some, it becomes quite an obsession. So this is actually a pretty exciting story, Fred, and I'm glad that we're talking about it because it's not what's going on in space, but it's how we humans are relating to space.
You sound almost as though you're speaking from personal experience there, Heidi, about obsessive coin collectors.
I'm not the obsessive coin
No.
collector, but I might know a few.
Yes, that's what I was wondering. It's true. It's actually, I think it's a pretty good hobby as well. If you're, it's some very nice things to display, and people do indeed take it very seriously indeed. So what this story is about is, well, more circles, not so much the coins, although they are spectacularly beautiful, and it's not too hard to find online what these coins look like, but the anniversary that they're celebrating. So let's cut to the chase. It's the Royal Mint of Belgium and the Royal Dutch Mint that have struck these new coins. They're in euros, of course, the currency of Europe. One is a €2.50 coin. And the other one is a 50 cent coin. And they are both emblazoned with the logo of ESA, the European Space Agency, which is celebrating this year 50 years since its inauguration on May the 30th, 1975. I remember it well, actually, Heidi, because there were two precursor organizations, which we used to hear a lot about in the 1960s and 70s. Of course, the headlines were always being made by NASA with the Apollo program and its predecessors, Mercury and Gemini. Those programs were what we lived and breathed, actually, at the time, those of us who were space fanatics. But the Europeans had two organizations which were called ELDO and ESRO. ELDO was the European Launcher Development Organization, and ESRO was the European Space Research Organization. And if I remember rightly, the United Kingdom, where I grew up, was in one of them, and I can't remember which one it was, and I don't think it was in the other. I think it might have been ESRO. I was at, not very long ago, last year, I was at a place called Woomera in South Australia, which was another name that was very familiar to all of us space geeks in the 50s, 60s and 70s, because that was where British rocket experiments took place. It's a very barren part of Australia, although there are traditional owners who live there, and many rocket tests were carried out there. Most of them ceased in the 1990s, early 2000s, although there's now new work going on. But I had a chance to visit it last year. There's a fabulous museum there with all these all these 20th century rocket examples. But there is an ELDO hotel. It's called the ELDO Hotel, and it comes from the European Launcher Development Organization. So it's a name that probably most people these days wouldn't recognize, but ELDO was that very important organization, which eventually melded with the European Space Research Organization to become ESO. I beg your pardon, it became ESA. ESO is the European Southern Observatory. ESO is the European Space Agency, which is what these two organizations turned into. 50th anniversary, ESA has done an extraordinary job over the past 50 years, working a lot with other agencies, most especially with NASA. Of course, ESA is a partner in the International Space Station, and it's very, very capable indeed in terms of the not just the human spaceflight missions that it has been involved with, but also the robotic missions. Gaia, just to bring one to mind, which is a very important astrolometry satellite, a satellite measuring the positions of stars very accurately. That was an ESA project. In fact, there was an ESA lander that went to Titan with NASA's Cassini spacecraft, and that lander, which was called Huygens, that landed on the surface of Titan. That was an ESA spacecraft, and many, many more. I could go on, but I won't, because the bottom line is that ESA is a very productive organization, and we're now celebrating with these two lovely coins.
So, Fred, I wanted to ask you if you knew, I have the coins pulled up on a big screen right now, and I'm looking at the design, and the design looks significant. I don't know if you can see it, but there's the side where it has the 50-year anniversary, and then it looks like a star spinning around on some kind of an orbit. And then the other side of the coin, the where it has the 2.5 Euro. Obviously, Europe, I recognize that. But the lines on the left, correct me if I'm wrong, was that from Voyager? Are you seeing what I'm seeing?
Yes, I am seeing it. I can see what you mean. They may be. It may be. They look like the ones that I'm thinking of are on the Pioneer spacecraft, where they drew lines on it to show where it had come from in relation to quasars in the sky, and it may be something like that. I can't quite make out enough detail just to know what they're depicting there, but it does look something like it, doesn't it? Very like the Pioneer plaque.
Very much so, yeah. Well, here's a series of scavenger hunt then for our listeners. You guys can see if you can figure out what the puzzle is on these coins, and then write back to us or comment on our social media and let us know what you think the lines mean. I'm going with Voyager.
Okay, go for it. There's a symbol there as well, which is underneath the date. I don't know what we're seeing there. It almost looks like spacecraft.
It looks like, I don't know, I'm trying to figure that out too. It looks like a seashell on the left and then like the medical symbol on the right.
Yeah, maybe. Well, there must be an answer to that, which hopefully we'll discover on a later edition of Space Notes.
Absolutely. Well, thank you. What a cliffhanger to leave this episode off on. You guys have to go put on your detective hats. And while Fred is exploring the mysteries of the universe, we can all be exploring the mysteries on this coin. But thank you so much for everybody who has joined us for another episode of Space Nuts. And we will be seeing you guys next week. See you later, Fred.
Thanks again, Heidi. Take care.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.